Example 4.1 is going to give us a look at what many of the questions are going to look like for transformations. So it says here, use the graph of y equals f of x. So the graph, which is provided below, is not one of our basic parent functions. However, it is a piecewise function. Now the reason why I can see that it's a piecewise function is this first piece that I've highlighted looks a lot like the identity function, and the second piece that I'll highlight next is a constant function. So I'm taking two functions that we already know, and I've pieced them together. So I didn't necessarily want to have to give you the equation for that, but I still wanted you to be able to manipulate and perform a transformation on this shape. So let's look at what we're supposed to do to this. What we're supposed to do is create a new function called g of x. And g of x is equal to f of x minus 3. So f of x is mentioned in the equation for g of x, but it also has this subtraction of 3. So this is saying that g of x is, so anytime you see an equal sign, that means the word is. So if I'm reading this statement from left to right, I would have g of x is f of x minus 3. So according to our definition for vertical shift, if I take a shape, which is what I have right here, this is my my shape, which in this case is not a parent function, it's a piecewise function that I've shown you already, then this tells me what I'm supposed to do to be able to create this new version of the function, and we're going to call the new version g. So that minus 3 right there tells me that I am going to shift down by 3. So I'm going to take all of the points that are in f and I'm going to shift them down by 3. Now this is an infinite map. There is an infinite number of points here, so it's not going to be reasonable to try to take every single point and do that. So you pick some sample points. For example, I pick the point at negative 2, 1. I shift it down by 3, and it'll be down here at negative 2, negative 2. Next good sample point would be at negative 1, 3. Shift that down 3, and now it's sitting on the x-axis. And I'll do the same thing with this point on the far right at 2, 3. That will also be shifted down 3 to be sitting on the x-axis. And I can connect these with straight lines, just like the original function f was. And now I call this g. So it still looks like f, except it's been shifted down by 3. Notice that we don't have to use a table to create this picture. All we have to do is understand how the algebraic equation is translated into the geometry.